Hello guys, you are welcome in ECE 303 from University of Kufa. In this part and next ones, we will demonstrate examples of different transmission lines like two-wire or coaxial cables or microstrip line, and also we will explain how the characteristic impedance of any one of this transmission line could be calculated and how it's varied with several parameters, like for example here in case of two-wire line we will see how the characteristic impedance varied with the diameter of the wire, the conductor itself, and the distance between the two wire, and also the frequency of the electrical signal or the electromagnetic wave which is applied to be traveled through these transmission lines. Beside that, also we will calculate some other factors like attenuation coefficient, phase constant, and of course to calculate the characteristic impedance, the capacitors and inductors and resistors. And so for example here, first we have two-wire line, okay, with conductor diameter small d and distance between them capital D. Okay, so we need to calculate the characteristic impedance for such shape of transmission line. We need to calculate C and L and R and G, and of course all of them per unit length. And to do that, we know we could use these equations or formulas to calculate the main sheet parameters. So for example here we have case of two-wire, so we could calculate the resistor here and the inductor and the conductance and the capacitor. Okay, so by calculating these four parameters we could then calculate the characteristic impedance. Okay, so now let's for example start with change the diameter of each conductor. Now we have 1.5 millimeter. If we decrease this, we see the impedance, okay, here the characteristic impedance here, it's increased when we decrease the diameter of the diameter of the conductor. So when we have 0 diameter we get infinity characteristic impedance. Okay, let's back to 1.5. Yeah, it should be here approximately. Okay, what about the distance between the two conductors? When we decrease this distance, the characteristic impedance will be decreased. Okay, and here if we change the frequency, if we applied range of frequencies on these transmission lines, we see the characteristic impedance keep constant. That means this transmission line is dispersionless. Okay, and this transmission line could carry wide bandwidth, wide range, could carry signal with wide bandwidth, a wide range or wide range of frequencies. Okay, could carry any signal with any frequencies. So this is for the two line. In case of transmission line, coaxial cable transmission line, we have two conductor wire also, but one inside the other. Okay, so the first one is called the core and the other one is called shield. The core, it has diameter 2a, and the shield, it has diameter 2b. Okay, so according to this table, we need to calculate R, L, G and C from these equations, and then use this parameter to calculate the characteristic impedance, okay, by this formula, of course by using the angular frequency also. And we could also calculate the alpha and beta by using the parameter R, L, G, C, okay, to calculate attenuation coefficient and phase constant. So now, if the diameter of the core is increased, we see the characteristic impedance here will be decreased. So it's inverse proportional with the diameter of the conductor, and when it's decreased, it will be increased. So what about the diameter of the shield? Okay, when we increase the diameter of the shield, that's mean increase the area or the volume of the dielectric material, the characteristic impedance will be increased. So it's proportional with the size of the dielectric material. Also, regarding the frequency, this coaxial cable is designed to carry out, okay, signal with wide range of frequencies, so the characteristic impedance, it keep constant for a wide range of frequencies. So I think this is good for this part, the two wire and the coaxial cable. And the next part we will talk a little bit about the microstrip and then demonstrate the model of the low losses microstrip line.